Hey everyone, Geophysicist Stefan Burns here. There has just been an anomalous 3-hour geomagnetic storm that kind of came out of nowhere. The rating goes all the way to 9. Then all of a sudden, boom, 5.67. Big increase in the KP index and not really directly connected to space weather. We'll look at the parameters for the solar wind, and you can make a case that it was a solar wind influence, but if it was, it's still bizarre. Because actually, just in general, the past month has been quite bizarre across a wide range of things. So we've had anomalous increases in solar radio flux. We've had anomalous decreases in cosmic rays coming into the planet. We've had strange embedded, like, high density plasma clouds within the solar wind that hit us when the plasma density was around it very, very low. We've had just some strange activity in general. And so I don't know what this is. Like, I don't claim to know everything. We're just going to look at this very much from an observational standpoint, and maybe we'll be able to put some things together in the video. But regardless, we know that we're in some big Earth changes at this moment in time. And really, my intuition, if I did have to put a little bit of like my thoughts on this down, write them down, I would say it's probably due to some things occurring deeper within the planet, changes in the core. So we had this magnetic jerk that occurred on our planet just in the past few hours, and we have some significant space weather that is just passed by us. We have more significant space weather coming up. This is our 193 angstrom view of the sun. We see this very large coronal hole here. It's done 6 rotations now, perhaps more, but really 6 in its current form. So it's quite large, quite active. It's after this has gone geoeffective that we've had 2 high magnitude earthquakes. Back in July, this went geoeffective, hit us with a high-speed stream. Then we had that magnitude 8.8 megaquake, boom shakalaka. Then in August, we had this also hit us with its high-speed stream. And then shortly afterwards, we had that magnitude 7.4, I believe, Drake Passage. 7.4 or 7.5, one of the two. Both big earthquakes. So this one in particular seems to be an earthquake breeder. It seems to like to create these earthquakes here on the planet. We're seeing maybe these changes with the core. We are in solar maximum, meaning that there is just in general a stronger electric current that flows down the ecliptic plane of interplanetary space towards the sun. And that energy does not come in through the poles of the planet. Let's say this is Earth. It does not come in through the poles like the magnetic field. The electric current, at least the foundational heliospheric electric current, comes in right at the equator. And that in general just heats up the Earth and triggers a lot of very significant energetic changes across our planet. And really it actually guides the geologic evolution of our planet. So we may touch on that a little bit too. But let us get right into these fluctuations. So here we have the video for that, and we're going to look at the live feed, but I had to capture this video because it's only 3 hours of live data, and I wanted to get this burst before it disappeared from the live feed. So we're looking at our northern hemisphere here, the North Pole, and then we also see the southern hemisphere, the South Pole. I'm going to turn myself off, and you are going to see this recycle right here. Now we're looking at it, and you'll notice a big pulse of dark red color hit both right there, the north and the south. And it was from 2100 to 2400 UTC that we had that G2 minus geomagnetic storm, because it was a 5.67. So that makes that a G2 minus storm. And from all the space weather impacts that we had over the past few days, we actually never even got to that level. So this is the highest level of geomagnetic volatility that we've had in some time, and the solar wind conditions are effectively flat and normal. But you'll notice that there is a very clear pulse of activity that occurred both near the North Pole and, well, the North Magnetic Pole and the South Magnetic Pole, right, located in both the hemispheres. and then there's continuing fluctuations after that. But look at that, it really kind of like grew and pulsed forward, and then we see these residual vibrations that occurred afterwards. This is our scale here. So this is measured in nanoteslas. It goes up to dark red, but actually it can go off scale. Anytime you see like that dark red color, you're talking about a 400 nanotesla or plus greater swing. Normal diurnal variations, 24-hour variations due to electric currents in the ionosphere, which generate magnetic fields because of solar radiation on the daylight side. That occurs once per day, depending on where you are. And everywhere has different ionosphere currents, so the diurnal variation is different. But those are typically about 30 to 50 nanotesla in strength. So when you're having these sort of geomagnetic fluctuations from usually space weather, going up to 400, 500, even like 1,000, 2,000, 3,000, if it's really wild, that's a lot bigger than these diurnal variations that we experience on a day-to-day. So we are used to these diurnal variations of the Earth, the magnetic field, and our circadian rhythm aligns to that. And when we get these sort of random fluctuations that really just spike, that also alters our biophysiology. So from down to the atomic level, we resonate with that in a variety of ways. So let us look at our real-time solar wind and maybe do a little bit of detective work on this, see this KP index high that we just had. This is very weird. So let's check it out. Here we have this, and this is provided by NOAA. This is the space weather portal that they have. And come on. And so here we go. Yeah, so we see up top our interplanetary magnetic field. We'll talk about that. Here's our phi angle. We have our solar wind density, solar wind velocity, solar wind temperature. And then at the very bottom, we have our KP index, okay? And lo and behold, there it is. There is our G2 minus geomagnetic storm, kind of coming out of nowhere, like really out of nowhere. I mean, I loaded this up today. I went off to the gym and did a whole thing. It was really, really nice. Took like a vacation day. I got back and was like, wait, what? What? Like, how did that happen? Because we had that solar impact back here. We had not only a coronal hole high-speed stream hit us, but also a solar storm launch. And it's actually kind of two of them that combined together. And so we immediately went up and had heightened geomagnetic volatility. We had a geomagnetic storm, though it was weaker than expected, which is it was bizarre. The fact that this storm was weak was weird. Because our velocity there, check out our velocity. I mean, velocity went all the way up to 650 kilometers per second, and then the solar wind magnetic field went all the way past 20 nanotesla, as you can see up there. And the stronger that is, the deeper it pushes in to Earth's magnetic field. You have a magnetopause, the zone where the magnetic fields are equal between the Earth and the sun. And at the magnetopause, you actually get these complicated electric circuits that form, kind of like in this spiraling fashion out, and then they go behind the Earth. It is a very complicated system, the magnetosphere and the electric system and everything. But in general, the solar wind strength is normally 5, and so it would connect at where Earth's magnetic field is only 5 nanotesla in strength. That's where they form this equilibrium. When it's 20, that pushes in quite a bit deeper into Earth's energy system, the magnetosphere, the plastosphere, everything. And so the fact that this only reached a high value for 3 hours of 5 was bizarre. And then the solar wind density dropped. This is something that we've been tracking quite a bit on the channel. These anomalous solar wind density drops seem to be connected to elevated earthquake activity, specifically higher magnitude earthquakes. And well, I put out an earthquake watch when this storm came in, and then we had this low density zone, and we've had the strongest earthquake in some time, like, you know, a couple weeks or so, right after this anomalously low density zone there. Usually takes some time, like up to a day afterwards, if it's going to happen, to do that. It's not always right in the low density zone. Sometimes it's after you have that impulse. So we had a magnitude 6.4 in Vanuatu. That's the biggest earthquake for some time. We'll talk about the earthquakes as well. Also, we had a 5.8 earthquake near California, Oregon, near the Cascadia Fault. So that's been interesting. But we had this very low density going down basically like 2 orders of magnitude. I mean, we're all the way up here getting close to like 10 even for the density, but more like 5 or so. And then it goes here as flat lines. It actually probably dropped below 0.1. So going from 1 to 0.1, of course, that's a 10x decrease. So that's a 50x decrease in the density. And we actually don't know if it went below that because that's the limit of the sensor. But if you'll notice, right in here, we had these weird spikes in the density and also the velocity. So we'll zoom in on that next. But I just want to show you, again, this geomagnetic shock that hit us. So the magnetic field was basically calm and quiet after we had this storm. It actually really dropped anomalously low right when the density dropped, which is also weird. The solar wind velocity, like the whole thing just recently, this signature is quite odd, but it's not unexplainable. It's just very odd. You wouldn't normally see Earth's magnetic field behaving this way with this sort of setup, because the solar wind was still quite strong here. You know, 10, 12 is northward facing, but still solar wind velocity, it shouldn't have been this weak. Then it ramped back up as density went up, so velocity kept going down, the solar wind kept normalizing, but you'll notice it's kind of ramped up a little bit right here, so this become a little bit more chaotic. We did have a very slight southward component section there, which does align right before our KP index. So that is the most likely culprit for this sudden G2 minus geomagnetic storm, but it's still odd because these parameters are really nothing to write home about. 8 nanotesla, -3, 8, -6, that's a little bit more meaningful. But in general, this was pretty weak. And for it to launch us into the strongest level of geomagnetic volatility that we had of this entire storm structure, when we had much more intense things happening here, like I talked about, and we did have southward component there, it's just bizarre. It's very bizarre. And these sort of energy fluctuations, again, affect people individually, your health, your wellness, but also can affect just like kind of your thinking, and more headaches, pain, fatigue. These are common symptoms, but also like increased energy and some like enlightening thoughts and maybe realizations. That's another like expression of these energies at the individual scale. But collectively, they just seem to create greater chaos overall. And that can be chaos funneled towards good or chaos kind of funneled towards bad. For example, there was just some strikes from Russia on Western Ukraine. I guess Poland maybe kind of got in that skerfuffle a little bit too. The story's still breaking right now. I don't really know. I just know that I've been to Western Ukraine and I was there when there were some airstrikes that were carried out by Russia, and it's not fun. But these sort of events usually correspond with these sort of things, just increase energetic volatility. It's an interesting thing to explore into more if you're interested in that. But this was quite sudden, and these, again, this KP index is measuring fluctuations to Earth's magnetic field. So we've had just a sudden spurt of increased intensity in these vibrations across the entire Earth. And maybe it was this, but I feel like that doesn't fully explain it. I feel like there's some other reason for that. And maybe it's this energy, rather than it's coming in from outer space, it's also pushing out from the Earth itself, because that is very possible. This is a flow of energy. And maybe I can pull a video up to show you Earth's magnetic field from that perspective. So let me go ahead and pull up a video for you on this to really show you kind of what I mean. And I think I definitely have some. Just gotta find it. We'll use this one right here. This is an animation that I made. This is a good one. Okay, so here we have an animation showing Earth's magnetic field, the flow of that energy, also the ionosphere as denoted by this kind of electrical boundary, lightning strikes, and this fluctuating amorphous force field, which is the Schumann resonances. You'll notice 3 colors in there. And those could be the different modes of the Schumann resonances, these extremely low frequency vibrations. So this is very interesting. You'll notice this flow of energy, okay? So when you have space weather coming in, like some sort of solar storm or enhanced solar wind or whatever, right? Even sometimes it's like a small blob of plasma just kind of squarely hits the earth and causes a little rattle. That's maybe what happened today, but we're not really seeing that again in the solar wind data, right? That's coming in and flowing down into the poles. And that's usually the culprit for this sort of geomagnetic activity. Because you have this plasma flowing down, the movement of charge carriers, ions, hydrogen, electrons, and other heavier ions, right? They generate magnetic fields, and that's what's causing these fluctuations because they're also undergoing their own rhythms and pulsations and more. So you have that, electric currents generating these fluctuations as they travel down the magnetic field lines. And the polarity of the ion determines kind of which pole it goes to, whether it's the magnetic pole in the northern hemisphere, which is a south magnetic pole, or the magnetic pole in the southern hemisphere, which is a north magnetic pole. So it's positive, negative, right? Well, you could notice how this is coming out of the earth, right? And here's going into the earth. You can also have energy, magnetic flux, push out of the earth. It usually happens on long geologic time spans where we get these magnetic anomalies. For example, just in the past 2,000 years, there's been quite a few times where the magnetic field strength dramatically increased in certain select parts of the world. That would be Hawaii around 1000 AD. That would be Mesoamerica around 1500 AD. That'd be the Levantine Basin around, I think, around 1000 BCE, like the Bronze Age. Western Europe around 1000 AD. There was a big magnetic positive anomaly. The field strength was very high in Western Europe, specifically right over France about 1,000 years ago. So you can get these bulbs of magnetic flux to push out, but perhaps we also sometimes see them kind of blip out at faster timescales. Maybe that's what happened today. You know, we had this space weather impact, but we've also had this very low solar wind density, like it really dropped off the scale. Maybe we had a little blip of magnetic flux finally able to push out. And so if it's magnetic flux, it's probably like a little blob of plasma that pushes out. We know that earthquakes, high magnitude ones, often have earthquake lights associated with them. You usually see them at night, and they'll cause the sky to glow, and you'll see them zap up really quick to the upper atmosphere and out to space. That's probably a blob of plasma coming out of the Earth directly from these intense energies in Earth's interior, then zapping up. And we see that earthquakes also across our limited record. You know, when I say limit, I mean like 50, 100 years, because the Earth is much older than that, so it's limited in that geologic time sense. But with our limited record, we also see that earthquakes can affect the magnetic field, create these long period magnetic fluctuations that are like an hour, 2 hours in length. Some, you know, they can also be shorter duration. It can cause anomalous waveforms in ELF and VLF fields. So this would be like 0 to 10,000 hertz. Even higher frequency energies can also be impacted by these sort of Earth changes. So bizarre stuff happening right now. If we go back to our real-time solar wind, let's punch in on this thing because this is odd and it's just weird. So let's just like give it a look and maybe we can just kind of ascertain what it is a little bit better. It could just be an equipment error, but I think there's this, it's just very bizarre. I think there's too many data points here for this to be simply the result of some erroneous data logging from this probe in space. We see that our solar wind density was very, very, very low. It basically completely bottomed, 2.1 particles per cubic centimeter or below. And then we see it went up. I mean, there was like 16, 8 for the density. The highest value there, I think, is 45. 45? What the heck? And that was with the normal velocity. And then it was these other values that we see the velocity went up to 857. So in general, just like these weird abnormal spikes in the density and the velocity within this extremely low density structure. Just we went through effectively a void space in the solar wind, and then our probes started to go wild. And our geomagnetic field got very, very quiet in this void. It's like all of a sudden you're in a sound room and there's all those panels up and you can't even hear anything if you're speaking. Like it's so quiet you can hear a heartbeat or things of that nature. So very, very odd signatures in the solar wind that popped up. I did just see a super thanks come in from Cliff. Thank you so much for the very generous super thanks. I will answer all the super thanks after the end of the broadcast. So thank you for your patience. So yeah, just kind of weird things. Now we do have something pretty notable coming up, and that is this coronal hole that I showed at the very beginning of the video. Here is that one again, 193 angstroms. This is our video for the 9th of September, Universal Time. But here we see the other 5 prior iterations of this coronal hole in our 211 angstrom view of the sun, which makes it a little bit more clear. But this differentiates it, the color, for what we just had, what's coming up right now. But it's a little bit darker and stands out a little better with the 211 angstrom view. So we see how this coronal hole has evolved. And what is a coronal hole at the beginning? Well, it's an area in the solar corona, which is the outermost atmosphere of the sun. That's right, the sun has kind of this nebulous, low density, but very high temperature and high energy plasma atmosphere that surrounds it. And then eventually you get deeper and deeper into the sun and it becomes more dense and actually gets colder and colder the deeper you go until you hit the surface. And the conventional model is that the surface of the sun is the lowest temperature and then it starts to rise up again. Whereas there are some other models that say that the sun does keep getting colder and colder the further in you go. It's maybe made of condensed matter, and there's a whole bunch of odd ideas with the sun. And there's probably some combination of them that's true. But these coronal holes are where there's not much plasma in that outer atmosphere. So you can think of it like the Earth, and it has its atmosphere, and all of a sudden there's just a chunk where there's more vacuum. And like, you wouldn't want to be there because you wouldn't be able to breathe, right? There's no atmosphere. Or if Earth is covered with clouds, it's an area that has like no clouds. You can kind of think of it like that. And it shows up dark, but it's not a hole through the sun. What happens is the magnetic field in these zones punches out and just extends really far out into space, whereas normally they form these loops because you have sunspots. We're in solar maximum, so the sun is at its most active right now. It's a 12-year cycle. 2025, well, 2024, 2025, and 2026 are basically the peak years of solar maximum, though I think 2026 next year is going to be more subdued than some people may think. But 2024, 2025 have been big years. And solar cycle 25 in general, this maximum has been stronger than expected, stronger than the last one. So you have to go all the way back to the turn of millennium to have a solar cycle that was as strong as this one. And this in general just increases energy flux across the entire solar system and the Earth. So it's kind of crazy to think that the sun doesn't affect the Earth when it's dragging the Earth and all the other planets through the universe at high speed, right? It's exerting gravitational forces on all the planets. We're all within the heliosphere, this big plasma bubble that's created by the sun. The Earth is only lit up and warm and energized because of the light radiation from the sun, ultraviolet, optical, thermal. Then there's also the radio frequency, microwave spectrum. There's also extreme ultraviolet X-ray light. Basically, our entire reality exists, and our existence is possible because of the sun. So it affects everything. So these coronal holes, these magnetic fields actually extend out. They can sweep by the Earth because they create these high-speed streams which hit the Earth. And we're very close to the sun at 1 astronomical unit. Jupiter's at 5, Neptune's at 30. On the larger scale of our solar system, those are pretty close to the sun because you can start talking about the Oort cloud, or you can start talking about the Kuiper belt, or you can talk about Sedna, which goes out to 1,000 astronomical units and then swings back in for perihelion every 12,000 years at around 76 AU, right? It has a completely different understanding of the solar system. The heliosphere goes out to 100 AU. At 1 astronomical unit, we are very, very close. We interact with these magnetic fields directly. So if these coronal holes get bigger, we need to be paying attention. And well, look at what happened. We've had this evolution. Here's April 30th. I have it centered. They go geoeffective when they're more in this position there on the side. So all of these are geoeffective about 2-3 days out from what I'm showing here with these, but we get the best view when it's dead on. Here's April 30th. We see these 2 coronal holes, but we see like this central zone that they're starting to vacate the material out of. Now we see it's a really nice scar, transequatorial, cutting across there. Here's mid-late June. This was quite large, though it did weaken out as it got to geoeffective position. This central portion there kind of started to regain some corona, and so that deficiency kind of filled in a little bit. And you'll notice that with our July 20th view here, it kind of formed this hammer shape, but in general smaller than it was back in June. Here is August, kind of looking similar. It's hard to say if it's bigger or not, but overall kind of like over a larger area, but definitely not fully, that coronal hole hadn't fully vacuumed out all the material, you could say. Well, this is now. And this would be showing up better on the 211 angstrom view, mind you. So we have a complete, uninterrupted, very large coronal hole on the sun. This is a coronal hole that swept by, swept Earth with its high-speed stream and that unique magnetic field right before, as I said earlier, that magnitude 8.8 megaquake and also that 7.4 Drake Passage earthquake, which was quite large, and that was in August, and then going back to the megaquake, that was in July. So it'd be these 2 coronal holes here. So look, it's gotten bigger. It's right in that transequatorial zone. It's not just slicing through with a ribbon like this. I mean, this is a fat coronal hole. This thing's been on a bulk. It's definitely been on a bulk, or actually a cut, because it's lost all its material. That magnetic field is really flowing out, and it's set to impact us right around September 14th. So let me pull up our NOAA space weather model so I can show you this. We have a lot of other things to talk about. This weird drop in cosmic rays, that was quite anomalous. Solar flux data and more. Earthquakes, we still have to get to that, but let me show you this. And here we are. Here we have our space weather model as provided by NOAA. And this is just set for ambient conditions because we don't have any solar storms head our way. We did just have a pretty large coronal mass ejection launched from the limb. I don't think they'll show it in this model. But look at this. This is that high-speed stream because this is our solar wind velocity. And you notice it's getting up there into the orange, even like kind of reddish colors. Look how it impacts right around the 13th, 14th of this month of September. So I'll zoom right there because this is the Earth there in green. Here's the sun. We're looking top down on the ecliptic plane. And here we see our cross section, which is south and north. So this is the ecliptic plane like that. Here's the Earth. There's the sun. And if something's going above the Earth, we see it go this direction. If you see it go below the Earth, it goes this way. This is our plasma density up here. You'll notice that there's a very low plasma density associated with these high-speed streams, which is again what we talked about, that weird anomalously low solar wind density structure. So I'm just going to scroll through this. We're going to see that the shock impact, like the front of it right here. That's at 10 a.m. universal time on the 13th, but then we will start to be in that high-speed stream after that. So the 13th, the 14th, even the 15th and 16th, it looks like we'll be in that coronal hole high-speed stream because of how large it is. If I go back to the video briefly, not that video, if I go back here, we see again just how wide it is. So we're going to be in that for a while. And in general, when we are in these coronal hole high-speed streams, there is just a greater likelihood of there being high magnitude earthquakes. That is based off of my observations. There is quite a bit of research on this. You can do your own research and think about it and make up your own mind. But time and time again on this channel, we've been talking about it and we've been seeing it. And it may not be, not every earthquake is magnitude 7, 8 or magnitude 8 and like, the most epic thing ever. It's really about what was like the average earthquake magnitude before, and then what was it afterwards? And did the high magnitude earthquakes for the time period align within these slots that we're looking at? And that's typically the answer. It's typically yes. So our earthquake activity actually has been fairly quiet, though we did have this magnitude 6.4 just recently. Here we have our USGS earthquakes map, and we see the United States. A lot of earthquakes actually around California today, by the way. Just for some reason, this is our 7-day view, but if I switch this to our 2-day, you'll see that it's actually quite a lot of them still hang out there. Look at that. So a lot of them just in the past day, and here's our 7-day. Now this is the biggest earthquake that's occurred in the past 24 hours or so. We see this magnitude 5.8 there. That was at 4:08 a.m. Universal Time on the 9th. And then we see also 5.1, 4.9. Let's see what the largest magnitude ones were. So 5.8, 5.1, 4.9, 4.9. So it's a pretty normal earthquake burst, but it's in an unusual location. It's right here on this spreading center on the Juan de Fuca plate and the Pacific plate on the other side. And then we have the Cascadia subduction zone, which is responsible for a magnitude 9 earthquake, or so we think. Could have also been like maybe a double or triple sequence of high magnitude 8s. But in general, magnitude 9 earthquake in the year 1700. That was very, very, very powerful, and people are waiting for that. They're like, is it going to happen? Some people are saying it's always going to happen tomorrow. Eventually it will happen. It's a geologic certainty, basically, that we will get another big earthquake there. And so this one, not exactly on the spreading center, though it's closer to that than it is the subduction zone, but it's fairly close to this triple junction here. But this is kind of bizarre. And you typically, to get a magnitude 6 or greater earthquake on a spreading center is pretty rare. They happen, but it's pretty rare. So magnitude 5.8 is getting pretty close to that. Usually the earthquakes on spreading centers don't go above magnitude 5.5. It's not impossible. Again, you can get magnitude 6s or even 6.5s. I think the highest I've seen is a 6.6 or a 6.8 on a spreading center. I'm not sure I've ever seen a magnitude 7 on one, but they can get big. But 5.8 is notable. But if we go here, we see the largest earthquake is actually here, Vanuatu, 6.4. This is 2147 universal time, depth of 10 kilometers. That's just the intermediate depth assignment. Maybe it was at 10 kilometers. It's hard to say when you get that value. They may not be able to accurately calculate the depth because this is fairly remote. 6.4 is fairly strong, but if you had a stronger magnitude earthquake, you could definitely calculate the depth. But where the near seismograms may be kind of far away. So it's hard to say why they put that value of 10 kilometers there. Could this be the default value? Could be the actual depth that it ruptured at. But that's the biggest earthquake that we've had in this entire 7-month stretch here. As you can see, this is set to show largest. We had this magnitude 6 there in Alaska. That was on the 3rd. And then we've had some other stuff recently. If I go to 30 days significant worldwide, we see that this magnitude 6.4, in fact, is the strongest earthquake since that magnitude 7.5 Drake Passage south of South America. So yeah, it was a magnitude 7.5. And I put out the earthquake watch right before this occurred. And then, it was just like a day kind of at the edge of my earthquake watch, like when it was wrapping up, I would say, is when this 6.4 hit. But I put out that alert because of the coronal hole high-speed stream impact that we just had with that solar storm and everything. And well, we had that low solar wind density structure. This was on the 8th of September at 2147 UTC, the Vanuatu quake. Let's check it out with our real-time solar wind. Let's do it. We can do it live. We can check out this connection between the anomalously low solar wind density and these high magnitude earthquakes. Again, that's the strongest earthquake we've had since August 22nd. So it's notable. That is what, like more than 2 weeks? I think it's like more than 2 weeks. So yeah. So we go to the 8th and we go to 2130 or so. It was right around there. And if I step over, you'll see Let me get this line back up again. 21, it's just right in this zone basically for that earthquake, the Vanuatu quake, okay? And you'll notice it's right after this super low solar wind density. We did go up, but then we had pockets where the solar wind density was low. And right when that basically came to a conclusion, because you'll notice there's no other low density pockets there, that's when we had that magnitude 6.4. So there definitely seems to be a connection between solar wind density and these earthquakes. And I think it's not the solar wind velocity, it's the main player. That may result in low density, but it really seems to be a low solar wind density, effectively less particles around space. It's almost like there's this expansionary effect that occurs because it's just like less confining pressure, and then because of that expansion, you're more likely to get earthquakes. We also had that eclipse on the 7th, the blood moon, right? I said the earth will shake when the moon turns blood red. And so this did not hit exactly during the blood moon, but actually maybe these signatures are from the moon. That moon was precise around this time frame right here. So some weird stuff occurred during that eclipse, which was visible for most of Eurasia. And then we had the strongest earthquake in 2+ weeks right around here, as we talked about earlier. So another weird thing that has occurred is this drop in cosmic flux. So we had this weak geomagnetic storm that was a G1 level, though we just had that G2 minus in the past few hours. But check out the 7th right here. We see that we in general had this decrease in cosmic ray flux. This is measured via a neutron proxy, but it's a good proxy. It tells us basically the amount of high energy cosmic rays coming into the planet. And these are pushed out to a greater degree during solar maximum. So you'll see here, actually, let's go here first. Here is our long time frame. Solar minimum is when you have very high cosmic flux, as you can see. And solar minimum is when you have very low cosmic flux, as you can see. This is solar cycle 25. And now solar cycle 23 was stronger in terms of sunspot numbers. It had, in general, higher sunspot numbers than this cycle. But you'll notice our cosmic ray flux has been quite low. There was actually significant length of time in solar cycle 23 maximum where the cosmic ray flux is higher than it is now. So this has really been a significant drop. Okay, so we're already on a decline with cosmic ray flux. We can see that we had some solar wind structures come in here. This is the last 30 days. So we hear September 1st, 2nd, 3rd, 4th, 5th, 6th. This is right around this geomagnetic storm. But look how it dropped, like negative 12%, like instantly, and then right back up. Very bizarre. Now we've started to climb back out, but in general, a very weird anomalous drop in solar wind, or in cosmic rays coming into the planet during that time. Very likely associated with that void and also that eclipse, because they both happened right there on the 7th. So this is showing, this is all universal time. And this is hourly averages. So this is looking like 1 a.m. on the 7th, universal time. Let's go back to our real-time solar wind, see if anything weird happened at 1 a.m. universal time. Well, we do see right at 1 a.m. is when we finally fell off the cliff with our solar wind density. So it looks like we didn't bottom out at 0.1. It looks like the solar wind density actually went super low because we've had density drops before that did not correspond to 12% decreases in cosmic ray flux that then bounced right back up immediately. So we must have really gone off the cliff with our solar wind density, and then we probably spiked back up like this before we went back down, and then we started to charge up. Like this might have gone down to 0.001. We don't know. 0.01. Who knows? We really don't know. But strange things have been occurring, and I think strange things are going to continue to occur. Here we have our radio frequency solar flux. This is our 2800 megahertz frequency emitted by the sun, or 2.8 gigahertz, a frequency very close to your Wi-Fi router. It is biologically relevant. It's also relevant as it relates to water dynamics and more. and this is backwards. So this is our most recent time here, and this is back in the very end of July. So we see solar flux is basically hovering around 150, a little bit of variation, but then you'll see that it went down here. We had very low sunspot count, rocketed up, and this is the end of August here. So we rocketed up, even at this spike over 300, because of a solar flare that occurred right when they recorded that data point. And these solar flares recently have been very strong with solar radio flux in that gigahertz and megahertz frequency band, which is kind of weird. Solar cycle 25 has that going for it as compared to other solar cycles, as far as I know with the data, in that it's been having stronger than normal radio frequency emission. Then we've gone back down now all the way to 125 or so. 121 is our most recent value there. So we're actually back lower than we were during this holding pattern, though not as low as we got here. We got down to 113 on the 18th of August. So big swings in solar radio flux over the past few months as well, as you can tell. Right? It's not like it's just been stable and humming along the whole time with just a little bit of variation, right? It was here, but then this big oscillation right there. Check out that sine wave pattern, right? There's clearly some big rotating structure, you know, sunspot related on the sun that's sweeping the Earth consecutively with these big increases in radio flux. And then at the same time, we're getting these changes as it relates to the coronal holes, right, and their high-speed streams. So this coronal hole down there has had 13 rotations. We're just seeing the tail end of it. It looks like it's starting to wrap up because it was smaller with this last one, but this one has been growing. And it may, you know, I may be able to track this one further back, but the coronal holes before the April 30th for this one really weren't all that epic or important as far as I remember. So it's a good place to start it for April 30th. So we can, you know, confidently say 6 rotations now for this coronal hole. Now it's taking on a unique butterfly shape, but the big takeaway here is that's really completely filled in like that. And so it's going to give us quite a wallop. It is a negative polarity coronal hole. And as a result of that, that is a stronger connection to the Earth. Positive polarity interacts differently. There's some very unique dynamics that take place with that, but a negative polarity really connects nicely with Earth. So we have that coming up. Now, remember I said that high-speed stream impact is expected to come in around 10 a.m. or so a.m. Universal Time on the 13th of September. Well, guess what, folks? We have some other things happening. So let us check out our recent coronagraph imagery. And to do that, we can check out our page here by NOAA. And we'll see this big explosion from the limb right there, very likely from sunspot group 4197, which was quite the entire Earth-facing journey, but decided to give us a big flare from beyond the western limb solar coordinate system. That would kind of be in line with 3i Atlas, by the way, just the opposite side. So 3i Atlas is off a little bit this direction right now. So kind of aligned with it a little bit, more so aligned with Mercury, right? Here's the deal. This is Mercury showing up in the coronagraph because it's performing a superior conjunction. So the term some people use for these is just Mercury Cazimi, but there's different types of these Cazimis. You have a superior conjunction where it goes in like this, and then you also have inferior conjunction where it's on the inside, because this is the sun. This little white circle there is the sun. They put a disk over it so we can see the corona and these solar wind outbursts and solar storms and more. Mercury shows up really bright when it's in that superior conjunction position because it's reflecting sunlight. And you'll notice it's inclined above the ecliptic plane, which is the Earth-Sun plane. So that flare is right out in the direction of Mercury. And so one of the things I've talked about on the channel a lot is how Mercury seems to be a very strong influence over the sun and its solar activity in a very like day-to-day time scale. Because all the planets have their own effects on the sun and there's certain boundaries within the sun that we've hypothesized that there's like these sudden changes in density and viscosity, and so you can create these abnormalities in them based off the planets exerting torque on them, like the trachycline, and there's a whole bunch of interesting stuff there, and these planetary resonances, how they line up with solar activity rhythms and more, and not just on that 12-year cycle, but like, you know, like a 108-day cycle, and you know, the Mercury cycle, there's the Venus cycle, Jupiter cycle, all these things. I don't think it's a coincidence that Jupiter's orbital period is like 11.88 years or so, basically 12 years, and that the solar cycle is also 12 years, and that we get solar maximum when there's an alignment with the sun, Jupiter, and also the center of our galaxy, which is interesting. So it all seems to be connected. But Mercury coming in for a superior conjunction very close to the sun, we're already seeing solar activity launch that way. It's going to be conjunct in that superior conjunction on the, guess what, 13th of September, when we have that high-speed stream impact. So Mercury is very close to the sun already, has very strong magnetic and has very strong magnetic field connections to the sun and very strong electric current connections to the sun because of its proximity. And you know, it's a big body that has, you know, this really no exosphere. It doesn't really have an atmosphere. It just connects directly to the planet. So like the Mercury's like just its body is like directly plugged in to the sun. And Mercury's always been seen, the sun and Mercury have always had this relationship, archetypally and mythologically. And we see solar activity already launching its way. Well, when Mercury is in that exact alignment with the Earth, we're going to be embedded within this magnetic field structure that emanates out from the sun, which has corresponded to sweeping bias in time just a couple days or a few days before the most recent big earthquakes. That 8.8 megaquake, Kamchatka, July 29th, 2025. This is Russia. That being the 6th largest earthquake ever on record with modern seismic gear. So a lot of loose threads that I'm doing my best to pull together in this, but just in general, we have some very significant things happening right now. That magnetic shock was quite interesting. Let me show you one more thing. We have some significant planetary geometry active right now. And so this is worthwhile looking at because this is active before Mercury's superior conjunction and also during, but it's also kind of most precise in some aspects right now. It's basically it's already started. So yeah, it's the 9th or the 10th of September, depending on where you are watching this right now. So we're getting close to the 13th. That superior conjunction is really like rapidly approaching. So here we have our solar system. The planets and the sun are not to scale, but their distances are, and also the position their orbits is the scale, the constellations and everything else. So it's a great visualization tool. And if they were to scale, you can actually change it so they're more like to scale, but that's not as easy to interpret. So we like them nice, big, and blown up. We like our Earth fat. So here's the Earth. We see Mercury on the other side, right? If I go to the 13th here, you'll see that they have this nice alignment, okay? See that alignment? That's that superior conjunction. And you know, it's around 12th to the 13th. I don't have the exact timestamp for you, nor do I think the exact timestamp is really important. Like it is, but I look at all these things as kind of having a window, and sometimes things occur slightly before or slightly afterwards, or sometimes during. But if you're looking just at like, oh, it didn't happen at 2:30 p.m., it's not going to happen. Like in terms of looking at an eclipse, right, that's going to be an exact time window. But for some of these other energetic events, it can be days in advance or afterwards. Well, in addition to this conjunction with Mercury, you'll also notice that the heliocentric geometry is that we have the Sun, Venus, and Jupiter in a line. So that's significant, holding down that section of the solar system, going out to 5.2 AU and creating a stronger gravitational vector. You have to consider that Venus is nearly as massive as the Earth, but it is closer to the sun. So Venus has a stronger effect on the sun gravitationally than the Earth does. Earth is special in the fact that it is still, you know, quite massive and a little bit more massive than Venus, but also has this magnetic field. So it has a very strong electromagnetic connection to the sun, and also has these gravity effects as well. But Venus has a stronger gravitational effect on the sun. So there's specific solar resonances that are linked to Venus cycles, which is interesting. And so it's extending that gravity vector from Jupiter, Venus to the sun. And oh, what's behind the Earth? Look at this. So you have Mercury on this side, and this is slightly skew from this alignment, but you also have Saturn and Neptune getting closer and closer to a great conjunction. This only occurs about every 35, 37 years. So this is a pretty rare event. Now, if we zoom forward a bit, we'll see actually their alignment is coming up right here in February. I think it's like February 20th or so, 22nd, 20th, right around there. That is when we get the geocentric conjunction between them. Late February, okay, mid-late February. Let's just put it at that. If I go back, okay, here's where we are. Let me go back to where we are. Right about here, let's say. Well, yeah, we can go for today. This is where we are right now. Let's just zoom forward a little bit and you'll see this intense planetary geometry manifest. Okay, so we already have one, but look right here. Now all of a sudden you get this alignment there. This is pretty interesting. We've been talking about this for more than a year now, and we don't know what it means. I'm not giving any precise proclamations of, oh, we're going to have exactly this. I've seen people do that mistake with planetary geometry, saying the moment we get this alignment, this volcano is going to blow up, and it doesn't blow up. So we don't know how these energies are going to express themselves. They can also express themselves like societally, socially, culturally, politically, a whole bunch of different ways, right? As we saw today with this burst of geomagnetic activity corresponding perfectly with this renewed aggression from Russia on Western Ukraine with strikes and a whole bunch of madness, right? Just doing stupid stuff. So I know a few things about that. But we notice this significant planetary alignment there, and this is happening right around the beginning of January. So we go into 2026 with this alignment and these guys getting closer and closer to their conjunction. But I've looked through the record quite a bit. I have more research to do on this, but we often see large volcanic eruptions or significant earthquakes or significant solar storms or solar activity during these sort of alignments. It's not all the time, but there is a little bit of an uncanny track record. And it's different each time. So it's hard, again, it's hard to pinpoint, but it just seems to be lined up with more significant Earth events to occur, or rather occurring. And so that's just kind of like the base definition, you could say. It just seems that more significant Earth events and usually geologic events occur around notable planetary alignments like this that form simple geometries that we can all see. So we have that coming up too. But we are ready right now in this pretty significant planetary geometry, because there's also, rather than just this alignment there or this one there with Venus and Jupiter, they are also making angles to each other. We're having this default planetary geometry that's active for a while because of this perfect relationship between Pluto, Neptune, and Uranus. These two are 120 degrees trine to each other. These are also 60 degrees to each other. Saturn is also configured with this. So we have this very nice geometric relationship, sacred geometry really resonating and just kind of holding that cymatic vibration in our local space. And then the inner planets and Jupiter are also doing other things at the same time. And so we have that unfolding, but it really gets active beginning of 2026 with that planetary geometry that I showed you. So that is the update for today. And yeah, a lot of very interesting things. Let me go through the super thanks and just address any questions that popped up there. And yeah, sunspot numbers right now are about 120. They are starting to go up again, but pretty slowly. And we can also just quickly look here. We can see our global seismic activity level. And you'll notice that after this big burst of earthquake activity, which we were accurately tracking on the channel, and we forecasted this megaquake pretty darn nicely, if I do say so. You see that things have cooled off. We had the 7.5 Drake's Passage, but look there. a whole bunch of days where the activity was moderate, or actually no low days, but all moderate, none of them high, until that 6.4 Vanuatu, which was right after the eclipse, right after that solar storm impact. That's when we had Uranus station retrograde. I talked about that. A lot of you guys watched the video. You know what the deal is. We look at our Schumann resonances. We can do this really quick too. We have been getting these interesting low frequency bursts of energy. Hard to say what that's from. It could be from very distant lightning activity. And the reason I say that is because that will generate an electromagnetic impulse across the entire spectrum. But the further away you are, you're only really going to receive the lower frequencies because the higher frequencies will attenuate out. So this could be reflective of thunderstorm activity further away from Tomsk, but still close enough to get picked up. This, though, does overlap in that geophysical range that's connected to space weather, with earthquakes, with changes to the Earth, weird energy emissions that sometimes happen. So that's what makes this kind of difficult to precisely say what it is. But we see this kind of continuously occurring now over the course of 2.5 days. There, and there. These lines are the Schumann resonances. 7.8 hertz, 14 hertz, 20 hertz, 26 hertz, 33. They apply a filter going from 32 hertz up to 40. 40 is the bottom of the axis there. And so they decrease the gain. So it makes it difficult to see anything that is higher frequency than 32 hertz. But you do get mode 5 there at 33 and mode 6 at 39 hertz. And these overlap perfectly with our brain waves, which go from 0 to 50 plus hertz. They have the same strength, frequency, and they've been humming and vibrating for millions, even billions of years. So that's a whole rabbit hole to explore. That's the first rabbit hole I probably explored on this journey of any significance, and it's still the most interesting to me. So significant Earth changes unfolding right now, but the biggest thing that we have coming up again is this coronal hole impact. So let me look through the super thanks and we will get that started. One moment. And let's see what we got. So thank you all for watching the live stream, everyone. I've been your host, Stefan Burns. I hope this taught you a lot. This is an educational live stream today. Also, just looking at all these different things. That's what we do on the channel. So if you like that, then smash that like button, help this channel grow. Please subscribe. We're on the road to 500,000. The channel's been blowing up like crazy. I just make videos and release them. I don't do any of these hacks. I've always just been 100% organic on YouTube. I think that is why the channel's done so well. And I just do my best to look at things authentically and from an open perspective, and just do my best to interpret it in a reasonable way while staying mindful of all the expressions of reality. So that's basically what we do on the channel. We have a super thanks here from Anna. Thank you so much. Then a super thanks from Obama Type Beat. October 16th marks the 40. Free fall begins October 9th for 7 days, of course. Front end now, rendering the back end day at a time. Okay, so you make it that way you will, everyone. Anna, thank you for another super thanks. Very generous of you. And another one from Anna. Wow, that's very nice. So thank you so much. Namaste. And then a question, also super thanks from Shannon. Thank you for the live updates to the sun's unique activity. I will keep you up to date with what is happening. That is my promise to you. Jason, thank you for the super thanks, bro. Good to see you here. And we have this question here from Cliff. Thank you. How close does 3i Atlas come to the Tesla Roadster Elon launch into space? Well, we would have to look that up. So that may be a little difficult, but let's see if we can do it. And it really depends. I mean, there's a few different apps I could go to, but I think this one will have it. No, there are some apps. Maybe I could do this. The Sky Live. Tesla Roadster. The SpaceX Roadster. And let's see if I can change this to, because there's like a 3D solar system viewer. So let's actually type in SpaceX Roadster. Maybe that does it. Well, in general, I really don't know. You can look that up yourself. There's a variety of tools you can use, Stephen, Cliff. That would be the Sky Live. You can use NASA's JPL database. There's a few of these. Just type in like solar system orbit diagram and load in 3i Atlas, load in the Tesla Roadster, and you can answer your question yourself. So that would be my recommendation to you. And another question here from Steven with a very generous super thanks. Thank you so much. What if the moon temporarily amplified the current Neptune, Saturn, Earth tidal forces and attenuated the magnetic connection, triggering the Juan de Fuca earthquake swarm from a deep mantle plume burp, which also produced the unexpected G2 storm? That is quite a sequence of events. In general, I try to stay away from very precise sequence of events like that because I don't really think the universe necessarily works like that. There is like this rhythm and a flow for sure. But it's just kind of like a resonance mechanism more so than like, this got severed and then that happened, because there's a lot of interconnected systems, which could very well explain how something like that could then maybe manifest, something downstream. But there's like these redundant systems too that kind of come in from the sides to kind of like patch things up. So if the moon temporarily amplified the current Neptune, Saturn, Earth tidal forces, I mean, we'd have to look at the Sky Live here to see that. Let's see what we got. And let's see where the Earth is right now with the sun. So you're asking the question, it's not a bad idea because the moon right now is on that side. If you zoom in here, see where the moon is, right? Just right after that full moon, right, the eclipse. Well, it's effectively aligned right now with Saturn and Neptune. So that is interesting. Who knows? I think it's great they're asking questions like that, and I do think things like that occur, and we probably don't catch them most of the time. So that's where I'll leave your question. Thank you so much for the super thanks. That could be a whole video discussion topic. That'd be interesting. Or what I'd recommend is someone to do a deep dive investigation into it and make a video on it. And you just present what you find. You don't have to create a fake story. You just simply present what you do discover. And I think people will resonate with that because it's interesting. So yeah, thank you so much. Then we have a super thanks from Charlie. Thank you so much. From Kim, I love your videos. My minor in college was seismology and geology. Thank you so much, Kim. That's awesome. Maggie Lee, thank you for the generous super thanks. Very fascinating. Thank you, Stefan. Just Breathe, another super thanks. Thank you so much. Thank you for your insight and knowledge. You are appreciated, and you are as well. Star Williams with the super thanks. The massive coronal hole looks like a butterfly. Yes, it does. We are in a period of transformation, that is for sure. Neptune is dissolving all the boundaries of Saturn. This is a rare moment in time where the structures that hold us back can be free. The chains are loosened a little bit. The Saturn-Pluto conjunction in 2020 was very authoritarian, very totalitarian. A whole bunch of bad things occurred in 2020, as we all know. So this Neptune-Saturn conjunction provides a little bit of relief from that. And maybe the sun is showing us symbolically some of those energies in play. And Anna, thank you for the super thanks. We love your authentic self and your amazing knowledge. Well, thank you so much. And the last one here from the Furries Visa, Together or Furies Visa, Together We Rise. Furries or Furies, you make up your mind. Thank you for the super thanks. So that is it for the live stream. Again, I've been your host, Stefan Burns, wishing each and every single one of you well. Please make sure you are treating yourself with care and respect. Not just now, but at all times. So this is making sure you drink good, clean spring water, eating whole foods, making sure you're staying away from the bad oils, excess sugar, all that junk, right? Breathe fresh, clean air, pump those lungs, get the heart beating every now and then, move your body, earthing and grounding, connect to the earth, decharge any excess energy, calm and still your mind every now and then with meditation, yoga, all these things are incredible to do. If you just make this into a daily habit and eventually becomes an unconscious thing that you do, then you're really going to live a wonderful life. And so these are all things that I'm actively learning and implementing myself day by day. And I would like just to share that advice with you during this Virgo season. So again, wishing all of you well. Thank you all so much. I'll see you all very soon.